We've all had that experience where we're driving along, maybe on an old county road or a beat-up stretch of interstate, and suddenly the noise stops. The vibration in the steering wheel disappears, and your car feels like it's gliding on air. You've just hit a section of fresh asphalt. Most people don't give it a second thought. They just appreciate the quiet and move on with their day. But if you stop and look at how that road actually got there, it's one of the most calculated and interesting processes in modern construction. When you see a paving crew at work, it looks like a mess of heavy trucks, steaming black piles of rock, and a slow-moving machine that looks like a giant flat iron. But that machine, the asphalt paver, is doing something that seems almost impossible. It's taking a bumpy, uneven surface and leaving behind a perfectly level ribbon of road. I want to talk about how that actually works, because it's not just about dumping hot tar on the ground. It's a delicate balance of physics, mechanical engineering, and a lot of human skill. To understand a paver, you first have to understand the problem. The ground underneath a road is never flat. Even after the dirt has been graded, there are always dips, ruts, and old potholes. If you just took a big blade and spread asphalt over those bumps, the new road would be just as wavy as the old one. This is what engineers call the smoothing principle. You can't just fill a hole, you have to bridge it. The secret to how a paver bridges those holes lies in a part of the machine called the floating screed. Most people assume the heavy plate at the back of the paver, the part the workers stand on, is bolted to the tractor. It's not. In fact, if it were bolted down, the road would be a disaster. Every time the tractor's wheels hit a bump, the blade would go up, and every time the wheels hit a dip, the blade would go down. You'd end up with a road that looks like a washboard. Instead, the screed is attached to the tractor by two long tow arms. The screed itself just sits there, resting on top of the hot asphalt mix. It literally floats. Think of it like a water skier. When you're water skiing, you aren't bolted to the boat, you're being towed. If the boat hits a small wave, it doesn't necessarily pull you under the water. You continue to glide on the surface. The screed works on the same principle of equilibrium. It has a specific angle, which we call the angle of attack. As the tractor pulls the screed forward, the hot asphalt flows under the plate. The weight of the screed pushes down, and the resistance of the asphalt pushes up. When those two forces are equal, the screed stays at a constant height. If the operator wants the road to be thicker, they tilt the front of the screed up just a tiny bit. More material flows under it, the lift increases, and the screed climbs to a new, higher equilibrium. If they want it thinner, they tilt it down. Because the screed is being towed from a point far ahead of where it's actually sitting, it takes a long time for a bump at the front wheels to translate to a movement at the back. By the time the screed reaches the bump the wheels just went over, it has already averaged out the height. This mechanical averaging is why fresh roads are so much smoother than the ground beneath them. But the screed can't do its job if the material isn't managed correctly. This brings us to the tractor itself and the head of material. At the front of the paver, there's a large hopper. A dump truck backs up to it, usually while the paver is still moving, and dumps a load of hot mix. This mix is usually about 300 degrees Fahrenheit. If it gets too cold, the bitumen, the black oil that holds the rocks together, starts to get stiff, and the screed can't glide over it smoothly. Inside the hopper, there are conveyor belts that pull the asphalt toward the back of the machine. Once it reaches the back, it hits the augers. These are giant screws that spread the asphalt sideways across the width of the road. This is a critical part of the process. If you have too much asphalt piled up in front of the screed, it creates too much upward pressure, and the screed will lift, making the road too thick. If there isn't enough asphalt, the screed will starve and dive, making the road too thin. The crew has to maintain a constant head of material across the entire width of the machine. On modern pavers, sensors watch this pile and automatically speed up or slow down the conveyors to keep that pile at the exact same height all day long. Now, even with the floating screed, humans wanted more precision. We wanted roads that were perfect down to the millimeter. So, over the last few decades, we've added electronic brains to these machines. If you look at a paving job, you might see a long 30-foot beam hanging off the side of the paver. That's called an averaging ski. It has several sonic sensors, essentially the same technology used in fish finders or parking sensors on your car. These sensors are constantly pinging the ground. They measure the distance to the old road surface at multiple points and calculate an average. This information goes into the paver's computer, which then controls hydraulic cylinders on the tow arms. If the sensors see a long dip coming up, the computer will automatically adjust the tow point to make sure the screed stays perfectly level. It's a layer of digital correction on top of the mechanical physics of the floating screed. In some cases, we even use GPS or robotic laser stations on the side of the road that tell the paver exactly how high it needs to be based on a digital 3D map of the project. But even with all this technology, paving is still a very human job. If you look at the back of the machine, you'll see the screed operator. This person is the DJ of the paving world. They have a control panel on either side of the screed, and they are constantly tweaking the settings. They aren't just watching the thickness, they're watching the texture of the road, what we call the mat. They're looking for segregation, which is when the big rocks and the small rocks start to separate. If that happens, the road will have pothole seeds, weak spots that will break open in a few years. They're also managing the vibration. Underneath that heavy steel plate, there are vibrating shafts. This isn't just for smoothing things out, it's for pre-compaction. As the screed passes over the asphalt, it's actually tamping it down. By the time the paver moves past a spot, the asphalt is already about 80% as dense as it needs to be. This is vital, because if the paver leaves the asphalt too loose, the heavy rollers that follow behind will just push the material around like Play-Doh, ruining the smooth surface the paver just created.
There's a real art to it. An experienced screed operator knows by the smell and the color of the mix if it's too hot or too cold. They can hear if an auger is struggling. They have to coordinate with the tractor driver who is trying to keep the machine perfectly straight while a 40-ton dump truck is leaning against the front of it. It's a slow-motion dance that requires a lot of communication. You also have the loot men, the guys with the specialized aluminum rakes. Their job is to handle the joints. When you pave one lane and then come back to do the lane next to it, there's a seam where the two mats meet. If that seam isn't handled perfectly, it becomes a crack. These workers use their rakes to blend the hot material into the old edge so that when the roller hits it, the two lanes fuse into one solid piece of stone. Once the paver has done its job, the rollers move in. These are the heavy steel drum machines that finish the compaction. But even here, the paver's work is what determines the quality. If the paver didn't lay a smooth mat, the roller can't fix it. The roller's job is just to lock the rocks into place. The reason we go to all this trouble, the floating screeds, the sonic sensors, the 300-degree temperatures, is that asphalt is a flexible pavement. It's not rigid like concrete. It's designed to give a little bit under the weight of a truck. But that flexibility means that any imperfection is magnified. If there's a tiny bump, every truck that hits it causes a hammer effect that eventually shatters the road. A perfectly smooth road isn't just a luxury for your car's suspension, it's an engineering requirement for the road to survive more than a few seasons of American weather. We're also seeing some interesting changes in the materials. For a long time, asphalt was just rocks and oil, but today we're using recycled tires, recycled shingles, and even warm mix technologies that allow us to pave at lower temperatures, which saves a lot of energy. We're even seeing intelligent compaction, where the rollers have sensors that tell the operator exactly how many passes they need to make until the road is perfectly solid. So, the next time you find yourself on a brand new stretch of highway, take a second to appreciate the quiet. Think about that heavy steel plate floating on a bed of hot stone. Think about the operator at the back turning the cranks and watching the texture of the mat. It's easy to think of construction as just brute force, big engines and heavy weights, and there's certainly some of that. But the asphalt paver is proof that there's a huge amount of finesse involved. It's a machine that uses the laws of physics to erase the bumps of the world 1 foot at a time. It's not magic, but when you're driving on a road that feels like glass, it's about as close as you can get. Thanks for taking the time to learn a little bit about what's happening under your tires. It's one of those hidden in plain sight marvels that makes modern life just a little bit smoother for all of us. Stay safe out there on the road, and we'll see you on the next one.